Good day, viewers. Welcome to this class. And today we'll be looking at likely GCE physics questions. Let's dive right into it. Question number 1 says, a solid weighs 5 Newton in air. So we have the weight in air. Weight in air as 5 Newton. And 4.2 Newton in water. So weight in water, 4.2 Newton, and 4.4 in liquid Y. So weight in Y is 4.4 Newton. The question is, calculate the relative density of the liquid. And we know that, so the answer is to find the relative density. We know that the relative density of any liquid is the upthrust in the liquid over upthrust in water. So this means that my relative density here is going to be weight in air minus weight in liquid Y over weight in air minus weight in water. That is the same thing as saying I have 5 minus 4.4 divided by 5 minus 4.2, and that will give me 0.6 over 0.8. So if I divide, that will give me 0.75. It means that the relative density here is 0.75, which is option A. Moving on to question number 2, it says, two forces forming a couple are separated by a distance of 25 centimeters. So our distance of separation is 25 centimeters. It said if one of the forces equals 40 Newton. So we have one of the force to be equals to 40 Newton. So what is the moment of the couple? We know that the moment is equals to force times the distance. So this means that the moment of this couple is 40 times. Now if you look at our distance here is in centimeters. So the first thing I'm going to do is to convert this to be in meter, because the unit of moment is Newton meter, which is what? Force in Newton and distance in meters. So this will become what? 25 divided by 100, because I'm having what? Centi here. So in order for me to convert from centimeters to meters, I have to divide by 100, because centi means times 10 raised to the power minus 2. So this is the same thing as saying that I have 25 here 1, 25 here 4. So I will have 40 times 1 over 4, which is the same thing as saying I have 10 Newton meters. It means that the correct answer to this question is 10 Newton meters, which is what? Option C. So that takes us to question number 3, which says, a radioactive substance has a half-life of 3 minutes. So a radioactive substance has a half-life of 3 minutes. So our T half here is 3 minutes. After 9 minutes, the count rate was observed to be 200. So our new count rate is now 200. What was the count rate at 0 time? So we are looking for the count rate at 0 time, we do not know. Now remember that they gave us that what? After what? 9 minutes, we now have what? A new count rate. So it means that the numbers of half-life that I have there is my time given over my half-life. That's the same as saying that the numbers of half-life that I'll be having is going to give me 9 minutes divided by what? 3, which will give me what? 3 half-life. So since I have 3 half-life as my numbers of half-life, it means therefore I'll tell them that the formula that I used to solve this question says that what? The new count rate is equals to the count rate at 0 time times 1 over 2 raised to the power of the number of half-life. So this is the same thing as saying that I have 200 to be equals to count rate at 0 time times 1 over 2 raised to power 3. So this is the same as saying 200 is equals to count rate at 0 time times 1 over 2 raised to power 3 here will give me what? 8. So this is the same thing as saying I have 200 to be equals to count rate at 0 time divided by 8. So I'll cross multiply. And when I cross multiply, you realize that when I multiply my 8 times 200, it means that the count rate at 0 time is going to give me 1600. So it means at 0 time, my count rate was what? 1600, which is option C. Moving on to question number 4. It says, which of the following is not part of an AC generator? Which of the following is not part of an AC generator? Now, in an AC generator, we have what is called the slip rings, we have what they call the carbon brushes, we have what is called the feed magnet, and we also have what is called the armature. But one thing that we cannot find in an AC generator here is the commutator. The commutator is present in a DC generator. And what does it do? The commutator helps to convert AC to DC in a DC generator. So what we cannot find in an AC generator here is the commutator, which is option A. So that takes us to question number 5, which says, in a simple pendulum experiment, a boy observed that the times for 30 oscillations are these. So we have what? The time for 30 oscillations given in the question. So we have the time for 30 oscillations as 70 seconds, 72 seconds, and 67 seconds. So at T1, this is T1, this is T2, and this is T3, given in the question, respectively. Calculate the mean period of oscillation of the pendulum. Now, the question did not ask us to find the mean time, but the word mean period. And how do we do that? We have to first get to what? The mean time. So my mean time is what? T1 plus T2 plus T3 divided by 3. So this will give me 70 plus 72 plus 67 divided by 3. So I'll have 70 plus 72 plus 67 divided by 3. So when I divide, I'm going to have 69.67. So once I've gotten this, I will now use this to calculate my mean period. And how do I do that? My period is equals to my time or my mean time divided by the number of oscillations, which will give me that I have 69.67 divided by 30, because in the question it said what? For 30 oscillations. So if I divide by 30, it means that my period will be 2.32 seconds. So it means what I'll be having there is 2.32 seconds, which is what? Option C. So that takes us to question number 6, which says a particle of charge Q. So we have a particle of charge Q and M moving with a velocity V. So we also have velocity V. Enters a uniform magnetic field B. So we also have the magnetic field. It has a mass of M. And we also have the magnetic field as B in the direction of the field. The force on the particle is dash. Now, in a magnetic field, the force in a magnetic field is always equals to QVB sine theta. This is the formula that we use for calculating force in a magnetic field. So, if our sine theta were to be 90 degrees, it means what I'll be having here is going to be times 1, which will give you what? QVB. Now, the mass is not needed. Now, looking at this would have been the answer if we are talking about the uniform magnetic field moving in perpendicular direction to the direction of the field. So if the particle was moving in perpendicular direction, our answer would have been QVB. But in the question, they say that it is moving in the direction of the field. And if it is moving in the direction of the field, it means that our theta here, our sine theta here will become what? Sine 0. And if I'm having sine 0, automatically, it means that my force will be 0. So in this question, because in the question it was made clear that this charge was moving in the same direction as the direction of the field, it means there is no correct option here that is correct. But assuming in the question it was said that it was moving in perpendicular direction, then our option A would have been the answer. So let's move on to the next question. So that takes us to question number 7, which says the helium isotope. So the helium isotope that I have there, there's a typographical error there, ought to be He32. He32. So this is the helium isotope that I have. So they're asking us how many protons are there and how many neutrons are there. Now, helium is number 2 on the periodic table. And because it is number 2, it means that the atomic number is 2. And the atomic number is always equal to the proton number, which means that in this particular helium isotope, what I have there is 2 protons. Why am I having 2 protons? I'm having 2 protons because your proton number is always equal to your atomic number. So if my proton number is 2 and I know that my mass number here, which is 3, is the addition of the proton and the neutron, automatically it means that my neutron present is 1. So I have 1 neutron and 2 protons. So it means that this helium isotope has, option A says it has 3 protons and 2 neutrons. That is incorrect. Option B says it has 2 protons and 1 neutron, and that is the correct answer. So the answer is what? Option B. So that takes us to question number 8, which says when a metal is heated to a high temperature, electrons are emitted from its surface. This process is known as dash. Option A says photoelectric effect. Option B says thermionic emission. Option C says feed emission. Option C says feed emission. Option D says secondary emission. And option E says radioactive emission. Now, when we talk about photoelectric effect, this is a phenomenon where electrons are emitted by light. So when light is incidented on a metal, electrons are emitted. It's called photoelectric effect because photons from that light is what causes that electron to be emitted. But when we talk about heat causing the emission of electrons, it is called thermionic emission. Therm here is what used for heat. Thermal, from the word thermal. So it is what? Thermionic emission. So the correct answer to this question is option B. So that is also question number 9. It says, a piece of stone weighs 180 Newton in air. So a piece of stone weighs 180 Newton in air. So if a piece of stone weighs 180 Newton in air, so weight in air is 180 Newton. And 150 Newton in a beaker. So 150 Newton. 150 Newton in methylated spirits. Containing 160 Newton of methylated spirit. So the beaker is containing 160 Newton of methylated spirit. What is the upthrust? Now, upthrust is not determined with the quantity or the mass of the liquid you are immersing your object into. Instead, it depends on the mass when immersed in that liquid. So, our 160 Newton of methylated spirit is irrelevant to the question. So, it means that my upthrust is simply the weight in air minus the weight in methylated spirit. So that will give me 180 minus 150, and that will give me 30 Newton. It means that the upthrust in this particular, the upthrust of this stone is going to be what? 30 Newton, and that is what? Option C. So that takes us to question number 10, which says the half-life of a radioactive substance is 2 seconds. So they've given us the half-life, T half, as 2 seconds. Calculate the decay constant. Calculate the decay constant. So we are looking for lambda, we do not know. And we know that our lambda, or my decay constant, is equal to, this is equals to 0.693 over T half. 0.693 over T half. So it means therefore that my lambda is equal to 0.693 divided by 2, and that will give me 0.3465. So it means that my decay constant is 0.347 approximately, which is what? Option D. And it's supposed to be in what? Per seconds, not seconds raised to power 1. This is seconds raised to power minus 1. So there is typographical error here also. It's supposed to be what? In per seconds as the unit of what? Decay constant. So moving on to the next question, which is question number 11. It says, which of the following is used in a nuclear reactor to slow down fast-moving neutrons? Which of the following is used in a nuclear reactor to slow down fast-moving neutrons? Now, in a nuclear reactors, your neutrons are constantly moving at extremely high speed, and in order to also slow down the rate at which they are moving, we would introduce a graphite rod. So what we use in slowing down fast moving neutrons in a nuclear reactor is what? Graphite rod. So the correct answer to this question is option A. So that takes us to question number 12, which says, when electrical power is transmitted over long distances, the voltage is stepped up so that power is transmitted more efficiently. Which of the following statement is correct? Option A says, the resistance of the wire may be increased proportionately to the power transmitted. Option B says, the time of transmission between the generating and the receiving stations may be reduced. Option C says, there is increased current to produce brighter light. Option D says, the rate of electrical consumption is increased. Option E says, the energy waste may be minimized as the current is lowered. Now, during the transmission of electrical power, they increase the voltage, and in the process, while they increase the voltage, there is a reduction in the current. So, as they increase the voltage, it lowers the current, and as a result of the reduction in the current, there is minimum waste of energy in the transmission process. So if the voltage is lower and the current is increased, there will be higher amount of energy that will be required to transmit that power from one end or from the point of production to a point where it is used up by the final consumer. So the voltage is stepped up so as to reduce energy required for transmission. That is wasted energy. So the correct answer to this question is option E, that talks about the energy waste may be minimized as the current is lowered. So moving on to the next question, which is question number 13. It says, a gas occupies a certain volume at, so we have a temperature T1 here as 27 degrees Celsius. And all I have to do here is convert it to be in Kelvin. This is plus 273, and this will give me 300 Kelvin. At what temperature? So we're looking for a new temperature. T2, we do not know. Will its volume be twice? So in first volume, our V1 here, it is volume. Our V2, it is twice the original volume. That's 2V. At what temperature will its volume be twice the original volume, assuming that its pressure remains constant? So this is Charles' law. So if we want to solve this question, we'll simply tell them that V1 over T1 is equal to V2 over T2 from Charles' law. So all you have to do here is impute a value. So we have V over 300 is equals to 2V over T2. So if I cross multiply here, I'll be having 600V is equals to T2V. So I divide both sides by V divided by V. It means that my T2 is 600 Kelvin. But if you look at our options, all the options there are carrying degrees Celsius. So in order for me to convert this to degrees Celsius, I simply subtract 273. So I have 600 minus 273. So that will give me 327. That should give me 327, and this will give me 2. So 327. So at the end of the day, I have what 327 degrees Celsius. It means that when the volume is increased, so long as the volume is doubled, your new temperature will be what 327. So at 327 degrees Celsius, your volume will be doubled. Moving on to the next question, it says, what is the coefficient of static friction between a load of mass 2 kg? So we are given a load of mass 2 kg. So we have a load of mass 2 kg. So we have the mass as 2 kilograms and a horizontal surface. If the limiting frictional force, so we have our frictional force as 10 Newton. We are given G as 10 meter per second square. So we have to find the coefficient of friction. So we are looking for mu. We do not know. And we know that from what we have done on frictional force before, that the frictional force is equal to mu mg. So this is the same thing as saying that my mu is equal to frictional force divided by mg. So it means that my mu, which is coefficient of static friction, is equal to 10 divided by 2 times 10, which is the same thing as saying that I have my mu to be equal to 0.5. So this means that the coefficient of static friction of this particular frictional force between a load of 2 kilogram mass is what 0.5. So moving on to question number 15, it says, when a lever is in equilibrium under the action of 2 or more forces, the algebraic sum of the moments of the forces about the point of support is dash. Now, according to the principle of moment, the total anti-clockwise moment must be equal to the total clockwise moment. It means that the total amount of forces at the pivot in equilibrium is always 0 because the anti-clockwise moment must cancel out the clockwise moment. So the total forces acting at equilibrium at the support point is always 0. So option A says that the forces about the point of support is anti-clockwise. Option B says it is clockwise. Option C says it's equal to the product of the forces. Option D says it is numerically equal to the total forces acting. Option E says it is equal to 0, which is the correct answer. It is equal to 0. That is what option E. Moving on to question number 16. It says, the specific heat of a substance in the solid state is C. So we have the specific heat in the solid state as what C. Okay? In specific heat in the liquid state from the solid state at temperature T. So we have a temperature T. The amount of heat required will be dash. So we are heating this particular substance from the solid state. We are converting it directly to the liquid state. Now, if there is a change in temperature without a change in state, without a change in temperature, it means that this particular substance will only have what? Latent heat. But in this question, they told us that this particular substance has a specific heat. So it has a specific capacity at the solid state. So which means that I'm converting this particular substance from the solid state. So my total quantity of heat here is going to be the specific capacity of the solid plus the specific capacity of the liquid plus the specific latent heat of the liquid. So here I'm having the total amount of what heat that will be what required to what convert it. So this is the same as saying that I have my quantity of heat to be equal to the mass of the substance times C here, which was given, times change in temperature, since they say that temperature is T, plus the mass of the substance times my C here is that of the liquid. So we can call this one C1. Let's say this first one is C1, and that of the liquid become what? C2 times change in temperature plus ml. So this is the same thing as saying that I have M in brackets C1 plus C2 close brackets, and here I have my change in temperature plus ml. So looking here, I discovered that what they both have change in temperature to be constant. So I factorize it out. Then they both have what? M to be constant. So I factorize it out. But what is connecting these two is addition. So what they did not have in common here is C1 and C2. That's why it is in bracket here. And this Ml is that of the what? Latent heat. I separated it. So what I have here is simply looking at our options. So we're looking for something that looks like this. So option A here, it is not related. Option B talks about it all having only latent heat. Option C is only talking about the latent heat without the mass. Option D here looks like what we have. Yes, option D. So the correct answer to this question is option D. Moving on to the next question, which is question number 17. It says, an element of nuclear number A. So we have an element. Let's say the element is X. It has a nuclear number A and proton number Z. Emits an alpha particle. So it is removing an alpha particle. So it is emitting an alpha particle. An alpha particle is a helium particle. So it is emitting an alpha particle. The nucleon number and the proton number of the new element. So we now have a new element Y. So they are asking us what will be the nucleon number and the proton number of our new element that will be formed. So looking at this equation here, you can tell that whenever an element emits an alpha particle, it is going to lose what? 4 from its what? Nuclear number, and it's going to lose 2 from its proton number. It means that what I'll be having on the nuclear number part is what? A minus 4, and on the proton number I'll be having Z minus 2. So we're looking for an option that has what? A minus 4 and Z minus 2. So looking at our option here, it means that what we have in here is option C, A minus 4 and Z minus 2. Moving on to the next question, it says, the force exerted on a uncharged body in an electric field depends on dash. So in an electric field, we know that the force is equals to QE, meaning that the electric field depends on the force exerted on the electric field depends on the charge, which is Q, and it also depends on the electric field. So it depends on the field and also depends on the charge. So we have Roman figure 1 here talks about what? The charge on the body. Roman figure 2 talks about the electric field intensity. Roman figure 3 talks about the square of the mass of the body. So it depends on the electric field intensity and the charge on the body. So looking at this, it means that it depends on I and II. So we're looking at our option for I and II, and that is what? Option C. So moving on to question number 19, it says a 400 gram of cold water. So we have the mass of cold water here as 400 gram. This is sitting as saying 400 over 1000. That will give me 4 over 10 kg. It's added to 200 gram of water. So we have mass of hot water here is 200 gram. So that will give me 200 over 1000. That will give me 2 over 10 kg. So we are given the temperature of hot water here as 70 degrees Celsius. So it said if they are mixed properly, if they are properly mixed, and the temperature of the mixture is 30 degrees Celsius. So the temperature of our mixture is 30 degrees Celsius. Calculate the initial temperature of the water. So we are looking for the temperature of the cold water. We do not know. So we know from the law of calorimetry that heat lost must be equal to heat gain. So this is mass of hot water times specific capacity of water times temperature of hot water minus temperature of mixture. This is equal to mass of cold water times specific capacity of water times temperature of mixture minus temperature of cold water. So my specific capacity will cancel out specific capacity. So here I have the mass of hot water here is 2 over 10 times my temperature of hot water there is 70 minus 30. This equals to 4 over 10 times my final temperature here was 30 minus temperature of cold water. So this will give me 2 over 10 times 40. So this will cancel this, is equals to 4 over 10 times 30 minus theta of the cold water. So this will give me 8 is equals to 4 open bracket 30 minus temperature of the cold water over 10. So if I cross multiply, it means I'll be having 4 open bracket 30 minus theta of cold water is equal to 80. So if I open the bracket, this will give me 120 minus 4 theta of cold water is equals to 80. So if I move this side and move this way, I'll have 120 minus 80 is equals to 4 theta of cold water. So this will give me, if I subtract these two, I'll get 40 is equals to 4 temperature of cold water. Divide both sides by 4 divided by 4. It means that the temperature of cold water is 10 degrees Celsius. So it means that the temperature of the cold water was 10 degrees Celsius before the hot water was added. So moving on to the next question, question number 20. It says the heat from fire in a closed room reaches someone far away in the room mainly by dash. Now, heat travels or transfers from one point to another using 3 different methods. We have conduction, convection, and radiation. Now, the heat in a fire can reach someone far away in the room by radiation, which is what? Through space. So the correct answer to this question is option D, which is what? Radiation. Moving on to the next question. It says, the clinical thermometer differs from other mercury in glass thermometers because it has dash. Now, what separates the clinical thermometer is first, its constriction. The clinical thermometer has what? Constriction. Then it also has what? A narrow tube. It has a narrow tube and it has what? Short range. So these three are what separates it. So let's look at which of them contains the 3 or contains at least 2. So constriction is Roman figure 1. Short range is Roman figure 3 and narrow tube is Roman figure 4. So we're looking for 1, 3, 4. Do you have anyone that contains 1, 3, 4? Okay, none of them contain 1, 3, 4. So let's look at 1 and 3. Do you have anyone that contains 1 and 3? So we have one that contains 1 and 3. So the correct answer to this question is option B, which is what? Constriction and narrow range. So looking at the next question, which is question number 22, it says, if a positively charged glass rod is used to charge an electroscope X by contact and an electroscope Y by induction, then dash. Now, when you use a positively charged glass rod to charge an electroscope, now, if you are charging it by contact, if you charge the electroscope by contact, the first electroscope that you charge, which you are charging by contact, will become positively charged. While the one you are charging by induction will become negatively charged. And since X was what? Charged by contact, it means X will be positive. And since Y was charged by induction, it means that Y will be negative. So let's look at the option that has to do with what? X positive and Y negative. Option A says X and Y will be negatively charged. Option B says X and Y will be positively charged. Option C says X will be negatively charged and Y will be positively charged. And option D says X will be positively charged and Y will be negatively charged. Like I said, X will be positively charged and Y will be negatively charged. And that is what? Option D. So that is also question number 23. It says, a wave travels a distance of 20 centimeters in 3 seconds. So we have the distance traveled by the wave. So the distance traveled by this wave is, so our distance here is 20 centimeters. And the time it takes is what? 3 seconds. It means that the velocity is distance over time, which will give me 20 divided by 3. Now, it is in centimeters here. Now, I'm not converting to meters because looking at the question, you can see that what? The distance between successive crests is also what? In centimeters. So the question says, the distance between successive crests. Now, the distance between successive crests is also called what? The wavelength. So our wavelength was also given what? In centimeters. So I have 4 centimeters. So this is in centimeters per second. So looking at this, so what is the frequency of the wave? Now we know that our wave velocity is f lambda, which is the same as say that my frequency is the velocity of the wave over the wavelength. So this means that the frequency of this wave is 20 divided by 3 divided by 4. So this is the same as saying 20 divided by 3 times 1 over 4, which is the same as saying I have what? 5 over 3. And 5 over 3 will give me 1 point. So that will give me 1.67 Hz. So the correct answer to this question is 1.67 Hz, which is option B. So moving on to the next question, question number 24. It says the unit of inductance is dash. Now the unit of inductance is Henry. That is what question, that's option D. Moving on to the next question, question number 25. It says a man at the back of a crowd watches a parade by holding a plane mirror just above his head. The parade passes 6 meters behind his head, and the mirror is 0.25 meters in front of the man. How far does the image in the mirror appear to be from the man? Now, looking at this question, you can tell that first, the distance between the image mirror to objects, from the mirror to the object, which is the parade, is going to give you 0.25, which is the distance between the man and the mirror, plus the distance between the man and the parade, which is what? 6. And that will give me 6.25 meters. And you know that with this, you know that the distance from the man, from the mirror to the image that will be created will also be the same as the distance from the mirror to the object. So this is the distance between what? The mirror and the image. But the distance between the man and the image, man to image, is going to be equal to the distance between the man and mirror, man to mirror, plus mirror to image. So we know that our mirror to image is the same as what? Mirror to object, which is 6.25, but the distance between the man and the mirror is 0.25, plus the distance between the mirror and the image is what? 6.25. So at the end of the day, the distance between the man and the image is going to be what? 6.5 centimeters. So the correct answer to this question, okay, is in meters, so this is 6.5 meters. So looking at this, the correct answer to this question is option A. So we have come to the end of today's class. I believe you had a wonderful time. Don't forget to go to the channel for more videos just like this.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Cacao,